स्क्रीन विजिबल आहे सगळ्यांना?
Yes, sir.
Okay. So we'll take one new problem and absolutely you have to help me for solving that problem. Because already, see, if you have doubt, no, you can ask here only. And while solving problems, some of the doubts will get clear. So I'll choose problem. Uh, oh. And keep in mind that concept is that always every link will have two components. मी आणखी एक विसरलो. How many components will be there of acceleration for a slider? Who can answer it? स्लायडर साठी ऍक्सेलरेशनचे किती कंपोनंट असणार आहे?
1, sir.
1. Okay. Very good. Pramod. Pramod, Surun, anybody else? In which direction?
Horizontal direction only.
Rakesh, horizontal. We cannot call it as a horizontal. It is in the direction of that
Of,
slider motion.
of the translation.
हा, म्हणजे त्या स्लायडर जसा मूव्ह होईल त्या डायरेक्शन मध्ये असणार आहे आणि त्याचा सेन्स जर स्लायडरचा सेन्स दिला असेल तर माहिती असणार, अदरवाइज वी कॅनॉट प्रिडिक्ट वेदर इट विल गो अप डाऊन लेफ्ट राईट. ओके, दॅट इज द केस. So a very simple problem it is, and we'll take it. No problem. Can you see this problem? Is it visible?
Yes, sir.
Okay. So this is statement of this problem. So I'll read this statement and we'll solve this problem step by step. Everybody has to take part into this and you have to tell me how you can solve this problem step by step. In a mechanism shown in figure, a slider C is moving to a right with a velocity of 1 meter per second. See here, carefully you have to read this problem. Listen me carefully. What is given? That slider is moving. Is it given that any link is rotating? No. It is given that slider is moving. Okay. So keep in mind that while solving it and while drawing velocity diagram, first vector which we can draw is the vector of velocity of slider. Even when we are going to solve this problem for acceleration, first vector which we can draw is the vector which is indicating acceleration of slider, not of any link. Okay, the previous problem which we have shown or which we have solved, that was related to the link. Now here motion of slider is given. Okay, 1 meter per second and an acceleration of 2.5 meter per second square. Acceleration is also given for the slider. It is 2.5 meter per second square. The dimensions of various links are AB is equal to 3 meter, inclined at 45 degree. It is shown here that it is inclined at 45 degree to the vertical line. BC is equal to 1.5 meter, inclined at 45 degree to the horizontal. Determine number 1, the magnitude of velocity and horizontal component of acceleration of point B. What? Horizontal component. Okay. It is written that horizontal component of acceleration. Okay. Of point B and the angular acceleration of link A, B and BC. It is asked that we have to calculate angular acceleration of AB and BC. That is nothing but alpha of AB and alpha of BC. Alpha is indicating angular acceleration. Right. So step by step we have to solve it. First step, what we have to do? Balaji Pise. Will you unmute? Balaji Pise.
Yes, sir.
What is the first step? What we can do first, Balaji?
So we take first stationary point.
First you have to take stationary point. Right. So I will take some stationary point for drawing what? Velocity or acceleration diagram?
Velocity.
Velocity diagram. Okay. What name I can give to this point?
AD. Sir, A.
A. Okay. Small a or capital A? Small a. Right. So Balaji has explained it that we have to take first step as we have to take one point from which we can draw that velocity vectors, and that point indicates stationary point. Okay. Before that, first of all, you have to draw space diagram. Okay. Space diagram is nothing but this diagram. You have to draw this diagram first on paper, and later on we can go for the drawing velocity diagram. गेटिंग मी आता ही डायग्राम ह्या प्रॉब्लेम मध्ये दिले, आता आपण ह्या स्लाइड वर पेस्ट केले, पण ज्यावेळेला तुम्ही पेपरवर हा प्रॉब्लेम सोडवणार आहे त्यावेळेला तुम्हाला हा या स्पेस डायग्राम अगोदर ड्रॉ करावी लागेल ऍज पर द इन्स्ट्रक्शन्स विच आर गिवन इन द स्टेटमेंट. स्टेटमेंट मध्ये दिलेल्या इन्स्ट्रक्शन नुसार आपल्याला स्पेस डायग्राम ड्रॉ करावी लागेल. बालाजीने अज्युम केलं की वी हॅव ड्रॉन दॅट डायग्राम. Okay, now slide over we can see this diagram. That's why he has told me that yes, we have drawn this diagram, we can assume it, and later on we can select or we can go further and take first step that we have to take one point which will indicate all stationary points. I'm saying all stationary points in this mechanism. It means that this A is indicating the point on which slider is reciprocating or sliding. म्हणजे हा जो A पॉइंट घेतलाय तो फक्त इथं A लिहिलेला आहे तिथला पॉइंट नाहीये स्टेशनरी पॉइंट. तो हा पण इंडिकेट करतोय ज्या ग्राउंड वर पिस्टन रेसिप्रोकेट होतोय किंवा स्लाइड होतोय तिथला पण पॉइंट आहे, तो पण A ने इंडिकेट केलेला आहे वेलोसिटी डायग्राम वर. Because all stationary points in the given mechanism will be indicated by a single point because they don't have any relative velocity or acceleration with each other. Getting me? म्हणजे बालाजीने आता जो पॉइंट आपल्याला सिलेक्ट करायला सांगितला कुठेही ऑर्बिटरी एका ठिकाणी, तो पॉइंट फक्त आणि फक्त तो ए पॉइंट जो स्पेस डायग्राम मध्ये दाखवलाय तो पॉइंटच असेल असं नाही, तर ह्या डायग्राम मधले सगळे जे स्टेशनरी पॉइंट आहेत त्यांना रिप्रेझेंट करतोय हा ए. ठीक आहे. नेक्स्ट, व्हॉट इज द सेकंड स्टेप? रोल नंबर 11, सुहास.
Yes, sir.
What is the next step?
Sir, I am joined now. I don't know what you asked.
Have you listened everything which we have discussed right now?
Now I joined, sir. You discussing about point A. Point A
ठीक
is
आहे, I will repeat for you. We are trying to draw a velocity diagram for the given problem. Now given problem we have drawn as per the instructions which has given in the statement space diagram. You can see this space diagram. ही space diagram आहे. ह्या स्पेस डायग्राम मध्ये असं दिलंय की इनपुट आपल्याला असं दिलंय की स्लायडर इज मुव्हिंग विथ लिनियर व्हेलॉसिटी ऑफ 1 मीटर पर सेकंड टू द राईट. राईटला आता सध्या हा स्लायडर मूव्ह होतोय 1 मीटर पर सेकंद अँड ऍक्सेलरेशन इक्वल टू 2.5 मीटर पर सेकंड स्क्वेअर. आणि राहिलेल्या लिंकच्या त्यांनी डायमेन्शन दिलेले आहे. AB इज 3 मीटर, BC इज 1.5 मीटर. And Balaji has told me that while drawing the velocity diagram, first of all, we have to take one point which will indicate stationary point. Then what is the next step? Suhas,
yes, sir.
what is the next step? Huh?
We have to draw first velocity of AB.
Velocity of AB, but it has not given in the problem that how the AB is moving clockwise, anti-clockwise, with what angular velocity. It has not given. It is given in the problem that piston is moving with velocity of 1 meter per second to the right. ह्या प्रॉब्लेम मध्ये लिंक रोटेट होते असं दिलेलं नाही. त्या प्रॉब्लेम मध्ये असं दिलंय की पिस्टन मूव्ह होतोय 1 मीटर पर सेकंद. पहिला वेक्टर कुठला ड्रॉ करायला लागेल?
BC. AC vector, I think. I don't know.
काय? ए हा प्लीज.
Don't know, sir.
स्वस हे उत्तर नाही. डोंट नो हे उत्तर नाहीये. And don't prefer to give this don't know answer. You can think that when you are appearing for the oral or for interview, just say don't know. That is not the case. हाँ सुहास.
Yes, sir.
Which vector you want to draw? जर प्रॉब्लेम मध्ये आपल्याला दिले असेल की पिस्टन मूव्ह होतोय 1 मीटर पर सेकंद, तर कुठल्या लिंकचा वेक्टर ड्रॉ करता येईल का आपल्याला? लिंक बद्दलची इन्फॉर्मेशन दिली आहे का कुठली? सुहास
कुठलं नाही दिली, सर.
हा कुठली दिली इन्फॉर्मेशन मग?
Slider C is moving
हा,
rightward.
स्लायडर सीच दिले, बरोबर आहे. तर स्लायडर सी कशावर मूव्ह होतोय? स्टेशनरी पॉइंटवर.
Hmm.
स्टेशनरी पॉइंट इथं काय इंडिकेट, कशाने इंडिकेट केलाय आपण?
A point.
ए पॉइंट आहे, बरोबर आहे. मग ए वर आपण जर उभा राहिलो, म्हणजे स्टेशनरी पॉइंट वर उभा राहिलो, सी जाताना दिसतोय राईटला 1 मीटर पर सेकंद.
Hmm.
मग आपल्याला कुठला वेक्टर ड्रॉ करता येईल?
AC.
1 मीटर पर सेकंद. हा, एसी, बरोबर आहे. हा, velocity of c with respect to a to the right and 1 meter per second, but we cannot draw directly 1 meter per second. We have to take scale. Okay, and we can take scale of 1 centimeter is equal to 1 meter per second. Okay, so when you are going to draw a line of 1 centimeter, it will indicate that it is 1 meter per second. So we'll draw one line which will indicate, vector which will indicate that velocity of piston with respect to stationary point, and which will be 1 centimeter. That is nothing but 1 meter per second. Assume that this vector is of 1 centimeter. At the tip of this vector, we can write, as we have drawn here, A. At the tip, we can have point C. One more thing, that why I have drawn this vector perfectly horizontally, because we know that all the points on slider moves parallel to the line of reciprocation. That's why parallel to the line of reciprocation, I have drawn that line. This vector AC, I have drawn parallel to the line of reciprocation. And this is indicating velocity of C with respect to A. Next step. Sujit Mane, roll number 39. Will you unmute? Sujit Mane.
Yes, sir.
What is the next step?
Velocity of BC.
Velocity of B
C.
with
CB.
respect to
Velocity
C.
of CB.
Velocity of C draw केली आपण.
With respect to B.
ओके, आता सी माहिती झालाय, त्याच्यामुळे आपण परत सी कडे जायला नको, आपण सी कडून बी कडे जाऊया ना.
Velocity of BC.
With respect to C, and how we can draw it?
Perpendicular to BC.
Perpendicular to BC, right? Do we know its magnitude? त्याची मॅग्निट्यूड माहिती आहे का?
No.
No, that's why we can draw line perpendicular to BC in downward as well as in upward direction. Okay, this is construction line. Right. Now, roll number 18, Sachin Sutar. What will be the next step?
Velocity of AB.
Velocity of AB. Now, we don't know B, we don't know A. Is it right? A माहिती आहे का B माहिती आहे
Yes, sir.
आपल्याला? Velocity of AB साठी
A माहिती. A माहिती.
A माहिती आहे. A मधून मग आपण line perpendicular to BAB draw केली. Okay, so wherever these two lines are going to cross with each other, that will be point what?
B.
B. Right. So when we are going to have the vector which is passing starting from point A and reaching to point B is nothing but the velocity of B with respect to A. Whereas when we are going to draw a vector from C and reaching to the B is nothing but the velocity of B with respect to C. Okay, so successfully you calculated or find out velocity of point B with respect to C as well as velocity of point B with respect to A. This vector is indicating velocity of point B with respect to C, and this vector is indicating velocity of point B with respect to A. So now what is the next step is that we have to draw a table, and for a drawing table, for filling that table, what we need is that velocities. Velocity of C with respect to A, velocity of B with respect to A, velocity of B with respect to C also. Just a minute. Sorry for interruption. So once you draw this diagram, you have to just measure this vector, multiply with the scale, and have the velocity of point B with respect to C. Also, you measure this vector and multiply with the scale and write velocity of B with respect to A. So for ready solution, I'll take this velocity of point B with respect to A is 0.72 meter per second. Velocity of B with respect to A is equal to 0.72 meter per second, as well as velocity of B with respect to C is equal to 72 meter only, 0.72 meter per second. दोन्ही पण वेक्टर तेवढ्याच लांबीचे आलेत आणि velocity of point B with respect to C is 0.72 meter. Also velocity of point B with respect to E is also 0.72 meter per second. ठीक है. Now next step is that we have to draw table. I'll copy this table as it is. You just tell me how we can fill that table. So serial number will be as it is. Link names will not be there. Then magnitude will fill. Then direction and sense. So which link we can take first? Yes. Which link we can take first for finding out the acceleration vectors? कुठली लिंक आपण पहिल्यांदा घेऊ शकतो? कुणी? हॅलो. Ajit Gaikwad, roll number 19.
Yes, sir.
Okay. Which link we can take first?
सर ज्या लिंकची व्हॅल्यू माहित आहे आपल्याला ती लिंक.
बघा. In the mechanism shown in figure, the slider C is moving to the right with velocity of 1 meter per second and acceleration of 2.5 meter per second square. What we can see from this? Slider is moving to the right with linear velocity of 1 meter per second and linear acceleration of 2.5 meter per second square. कुठली लिंक काढता येईल बघ? ज्या वेक्टरचे आपल्याला इन्फॉर्मेशन माहित आहे तोच वेक्टर अगोदर ड्रॉ करूया ना.
हा तेच ज्याचं माहित आहे ते आधी करायचं.
राईट. मग सांगा बरं आता कशाची माहिती आहे आपल्याला? स्लायडरचं ऍक्सेलरेशन माहिती आहे का? लिंक
Yes, sir.
BCM AC च माहित आहे?
स्लायडरचं माहित आहे आपल्याला.
स्लायडरचं माहित आहे. मग इथं आपण पहिली लिंक स्लायडर घेऊ. स्लायडरला
Yes,
किती
sir.
कंपोनंट असणार आहेत? रॅदर दॅन स्लायडरला कंपोनंट असतात का? लिंक ज्यावेळेला रोटेट होते त्यावेळेला त्याला दोन कंपोनंट आले. स्लायडर रोटेट होतोय का? स्लायडर स्लाइड होतोय फक्त. त्यामुळे त्याला दोन कंपोनंट घेतले होते का आपण?
नो सर, एकच कंपोनंट.
एकच कंपोनंट असणार आहे. ओके. That is nothing but acceleration of C with respect to A. Acceleration of slider with respect to stationary point. Okay. Magnitude is it given? 2.5 meter per second square. It is given in the problem. Otherwise, I will not prefer this link. जर मला हे माहिती नसेल तर मी या स्लायडरच्या अजिबात नादाला लागणार नाही, बिकॉज we don't know formally by means of which we can calculate it. फॉर्म्युला पण माहित नाही आपल्याला. आपण डिराइव्ह केलाय का तो फॉर्म्युला? नाही केलेला. फॉर्म्युला डिराइव्ह केला फक्त लिंक साठी. ओके. देन डायरेक्शन. जर स्लाइडर स्टेटमेंट मध्ये काय दिलं आपल्याला? मूव्ह टू द राईट. मुव्हिंग टू द राईट. असं इथं ऍक्सेलरेशन 2.5 मीटर पर सेकंड स्क्वेअर हे पण राईटलाच दिलंय. मग त्यांनी जर लेफ्टला असलं तर इट रिटार्ड्स असं म्हटलं असतं. इट रिटार्ड्स बाय 2.5 मीटर पर सेकंड स्क्वेअर. रिटार्ड जर म्हटलं तर इट इज इन द अपोजिट डायरेक्शन ऑफ इट्स मोशन. मोशनच्या अपोजिट रिटार्डेशन असणार आहे. सो इफ it is given in the statement that it is retarding with the 2.5 meter per second square, It means that in the opposite direction of motion, it is going to return. But it is given that it is accelerating and in the same direction by 2.5 meter per second square. आणि स्लायडरचं ऍक्सेलरेशन त्या स्लायडरवरचे सगळे जे पॉइंट आहेत त्यांचं ऍक्सेलरेशन पण लाईन ऑफ रेसिप्रोकेशनला पॅरलल असणार आहे. आर यू गेटिंग मी? सो इट इज अ पॅरलल to line of reciprocation. Horizontal म्हणू नका, because in some problems if the slider is not exact horizontal, then we cannot say it as a horizontal, it is moving horizontally. So we have to just say that parallel to line of reciprocation. Okay. Sense where it will go. It is given in the problem that it is going right. Okay. In the direction of acceleration. Accelerationच्या डायरेक्शन मध्ये. Okay. What will be the next step? Roll number 3, Gaurav. Will you unmute yourself, Gaurav? आता लिंक घेऊया आपण. रोल नंबर 30, राकेश बिराजदार.
Yes, sir.
हा, okay. Which link we will take now?
So we will take AB links.
AB, डायरेक्ट AB कडे जाऊया. आता पॉइंट C वरचा काढलाय आपण.
Then BC, sir.
ओके, ठीक आहे. BC घेऊया. BC ला दोन कंपोनेंट असणार आहेत का? लिंक आहे, रोटेट होणारी लिंक.
Yes, sir.
So acceleration of B with respect to C, centripetal component of acceleration of B with respect to C, and tangential component of B with respect to C. How we are going to draw centripetal component? Centripetal component is yes, काय फॉर्म्युला त्याचा?
Alpha into BC.
Alpha into BC. We know BC, length of BC we know, but alpha of BC we don't know yet.
Yes.
So its magnitude will be dash. How the centripetal components are moving, are drawn?
Towards the center.
Towards the center of rotation बरोबर आहे, सेन्स बरोबर आहे त्याचा.
Yes.
But they are parallel. All centripetal components are parallel to the link. Parallel to BC. ठीक है. And since you are saying that towards the center of rotation, and here we are going to see center of rotation is C now, because we are talking about the link BC, and C point is known, and we are moving from C to B. That's why we are taking center of rotation as a C. So towards C. Next component, which is tangential. of that length.
V square divided by BC.
B square divided by BC. Velocity of B with respect to C square divided by BC. Now here velocity of B with respect to C is 0.72 meter per second square. Length of BC is 1.5 meter. So can you calculate it for me? 0.72 bracket square divided by 1.5. How much it is? Yes. कुणी कॅल्क्युलेट केलंय का? कॅल्क्युलेटर आहे ना बरोबर? It's 0.77 meter per second square. Okay.
हॅलो सर.
And हा बोला ना.
सर ते ऍक्सेलरेशन ते हे चुकलंय ना, टँजेन्शियलच्या ठिकाणी हे झालंय.
हा हा टँजेन्शियलच्या ठिकाणी सेंट्रिपिटल झाले. नाही हे टँजेन्शियलच आहे.
नाही सर, एक्सचेंज झालेत फॉर्म्युले, वरचं खाली खालचं वर झाले.
ओनली साइन इज एक्सचेंज सर, साइन इज एक्सचेंज.
I'm sorry, is it right now?
सर
हा
टँजेन्शियल कंपोनंट आहे ना FBC वाला, मग तो परपेंडिक्युलर होणार ना आता?
टँजेन्शियल कंपोनंट इज परपेंडिक्युलर. हा पॅरलल नसणार. पॅरलल टू BC. And here it is perpendicular to BC. And tangential component is perpendicular to BC, but we don't know in the direction of alpha. It will be in the direction of alpha BC. Yet we are not knowing it, that's why I'll write here dash and parallel towards C. Right. Now next link we have to take as a AB. Tangential component of B with respect to A and centripetal component of B with respect to A. Tangential component is given by alpha of AB multiplied by length of AB. Yet we are not knowing angular acceleration of AB, that's why we have to draw here a dash. It will be perpendicular to AB. Acceleration direction we are not knowing, that's why dash. And next will be centripetal component of B with respect to A. And it is given by velocity of B with respect to A bracket square divided by length AB. So velocity of B with respect to A divided by length AB. So AB length is 3 meter and velocity of B with respect to A is 0.72 meter per second square. So can you calculate it? It is calculate केले का कोणी? 718 meter per second square. It is parallel to link AB and its sense will be, कोण सांगू शकेल सेन्स कुणीकडे घेऊया आता याचा सेंटर ऑफ रोटेशन? ए माहिती आहे म्हणून मी ए कडे घेतोय. Yet we have not find location of C on acceleration diagram, or we have not find the location of B. That's why we are going to take sense towards A because A is knowing, A is stationary, म्हणून आपण सेन्स A कडे घेतोय. ओके, ह्या टेबल बद्दल कोणाला शंका आहे का? Will there next any component or link? आता लिंकच नाहीत पुढं, त्याच्यामुळे त्याच्या पुढचे लिंक कंपोनंट किंवा काहीच नसणार आहेत. टेबल बद्दल कोणाला शंका आहे? हॅलो
हॅलो सर.
हा बोला ना.
सर ते मॅग्नेट्यूड काढलंय तिथं पी सी बी स्क्वेअर आपण बीसी आहे तिथं PCB 0.72 आहे ना?
हा 0.70 हे चुकलंय का मग?
0.72 आपण BC आहे ती 1.5 आहे.
नाही नाही 0.72 स्क्वेअर
आपण 1.5.
हा 0.72 स्क्वेअर डिवाइड बाय
आपण
1.5 किती येते?
0.345.
ओके 0.345. बाकी पुढचे एक
सर
दोन लेक्चर,
खाली पण
2-3 लेक्चर. हा बोला.
तिथं खाली पण चेंज आहे सर दुसऱ्या याला.
हा किती येते?
0.17 येते.
अ, 1.7 ना? 0.17 बरोबर आहे का?
येस सर.
Okay, 8 is also not there. It is 2. Right. So I request to everybody that next 2-3 lectures you attend these lectures with calculator. Okay, anything else? If not, we'll stop here. I'll take